All right, hi folks, this is Larry Mussolino. I'm recording a video for Module 6 homework for math, for our math course. And I wanted to go through a few of my math lab homework problems to help you get started. So why don't we come here to number 1 and we'll take a look at this. By the way, folks, remember, when you're in my math lab, you have these help buttons available to you here, right? So please be sure to use Help Me Solve This, View an Example, Textbook, Ask My Instructor. Ask My Instructor will send an email to me, okay? All right, so let's look at number 1 here. It says, find the values of x for which the given function is increasing and for where it's decreasing. So here's what we're going to do. We're going to use the first derivative to help us here. All right, the first derivative we write as f prime x, or you can write it as y prime. Either one of these notations means the derivative function. And here's what happens. When a graph is increasing, the first derivative is positive. So let me take this interval here from x equals 0 to, let's say, x equal 5. Well, notice in this interval, the graph is increasing. Also, maybe here at x equals 7 to x equal 10, the graph is increasing again. Increasing means the graph is going uphill. So we're increasing here and increasing here. Decreasing is when the graph is heading downhill. So let's say here the graph is decreasing from, let's say, x equal -2 to x equals 0. And then here again, the graph is decreasing from x equal 5 to x equal 7. Well, the key to this is checking the sign of the derivative. The derivative is the slope of the tangent line. So let me draw a few tangent lines on this graph to give you a sense of what's happening. I'm going to draw a tangent line back here. Let's say over here. Well, notice the slope of this tangent line is negative, right? It's a downhill line, which means it has a negative slope. So if the graph is decreasing, the slope of the tangent line is negative. That means the derivative is negative in that interval. Let me come over here. I'm going to draw the tangent line here. Well, notice that tangent line has a positive slope. So this slope is a positive slope. Well, that means the first derivative is going to be positive because the first derivative is the slope of the tangent line. Right? So back here, this slope is negative. So that's our thinking. Our thinking is if the derivative is the slope of the tangent line will tell you if the graph is going uphill or downhill. Because if the slope of the tangent line is positive, that means the tangent line looks like this brown line, but that must mean the red curve is going uphill if it's got a positive slope. On the other hand, if the slope of this brown line is negative, that means the tangent line is going downhill. It means the graph is going downhill. The graph is decreasing. All right, so that's the background. So here's what we're going to do. Step 1 is find the derivative function, y prime. Step 2 is set y prime equal to 0. Because when y prime is 0, you've reached either a maximum or a minimum on the curve, and that's going to allow you to set up these different intervals for positive versus negative. Then what you do is you mark so set y prime equal to 0 and solve for x. Then what you do is you mark these x values on a number line. Then we're going to pick a test point. Pick an x value. We call this a test point in each interval. Folks, I just want to make sure. Yeah, I just wanted to make sure that I'm sharing my screen, and I think I am. And I am recording. Okay, all is good. Pick an x value. This is going to be a test point in each interval. evaluate the first derivative at that test point. If the first derivative is positive, then the function is increasing. But if the first derivative is negative, then the function is decreasing. All right, so let's do this, work this out for this example. All right, so let's do step one, find the derivative. All right, well, if you remember, when you take the derivative of x to the third, anytime you take the derivative of x to an exponent, you bring the exponent down in front as a multiplier and you subtract 1 from the exponent. So the way I'm going to do this derivative is first I'm going to bring this 8 here with me because that's just a constant in front. The constant just comes with me. Now I'm taking the derivative of x to the third. According to this rule, that is going to be 3x squared. All right, I'm going to copy this 42 because that's a constant. And now I'm taking the derivative of x squared. The 2 comes down in front as a multiplier, and I subtract 1 from the exponent. That makes it a 1. And the derivative back here of 48x is just minus 48. The derivative of this constant 7 is 0. All right, let me just clean this up. This is going to be 24x squared minus 84x minus 48. All right, so we just did step one. Step two is set this derivative equal to 0 and solve for x. All right, well, it looks like I can do some factoring here. Can I factor a 12 out in front? I think I can, yep. So I'm going to factor a 12 out. That's going to leave me with 2x squared minus 7x minus 4. Okay. All right, I'm going to keep going and factor what's remaining. And so let me try to factor what's in the parenthesis here. So I think that can factor as 2x plus 1, x minus 4. All right, now I'm going to set each parenthesis equal to 0 to solve this quadratic equation. So 2x plus 1 equals 0, x minus 4 equals 0. I'll subtract 1 from both sides there. That's 2x equals negative 1. Divide both sides by 2. So I'm coming up with x equals negative 1/2. And here I'm going to add 4 to both sides. So I'm going to get x equal 4. All right. So I solved this quadratic equation. And let me write this up here just to save a little space here. So we just came up with the solutions that x was negative 1/2 and x equals 4. All right, so we just did step 2. All right, let's go to step 3. I'm just going to erase a little bit of this to make some more room here on the screen. All right, let's go to step 3. Step 3 says mark these numbers, these x values on a number line. All right, so here's a number line. And I'm going to mark x equal negative 1/2 and x equal 4. All right, now pick any test point in each interval. Well, really, I have 3 intervals I just created. I'll call this interval A. In the middle, I'll call it interval B and interval C. So I'm just going to pick any x values in these intervals. All right, well, maybe here I'll pick the test point x equal negative 1. In the middle here, I'll pick the test point x equals 0. And over here, I'll pick a test point, let's say x equals 5. All right, we just did step 4. Evaluate the derivative function at that test point. So if you remember, here is y prime. So let's do interval A. It's going to be y prime is 24 times negative 1 squared minus 84 times negative 1 minus 48. I just replaced this x with negative 1 because we're evaluating this test point here. Now, I don't really care about the actual numeric answer here. All I want to know is the answer positive or negative? So I don't have to bother working this out, but let me just, let's just do this quickly. This would be 24 times 1 plus 84 minus 48. Without working this out, I could see this answer is positive. All right, so we just found out that y prime is positive here. All right, let's do this test point where x equals 0. So this is going to be y prime is 24 times 0 squared minus 84 times 0 minus 48. Well, this is going to be 0 minus 0 minus 48. I could see that's going to be negative. So in the middle, this derivative is negative. And let me do one more. I'm going to evaluate when x equals 5. This is going to be 20 times 5 squared minus 84 times 5 minus 48. This is going to be 20 times 25 minus 84 times 8. Excuse me, 84 times 5. This is 420 minus 48. And when I work this out on my calculator, this I'm getting the answer of 32. So this is a positive answer. So here y prime is positive. Well, now I know the increasing decreasing conclusion. Because remember, if y prime is positive, then the function is increasing. So it must mean that the function is increasing here. This is from negative infinity to negative 1/2. And here y prime is negative, so that must mean the graph is decreasing in this middle interval. And over here, the graph is increasing. So it looks like the graph is increasing at x less than negative 1/2 and x greater than 4. So here it is, x less than negative 1/2 and x greater than 4 is increasing. Decreasing is this middle interval, right, between negative 1/2 and 4. So here is decreasing from x equal negative, between negative 1/2 and 4. Okay, so these are the steps, folks, to find increasing, decreasing intervals. All right, let's do another example. How about if we jump to, there's a few other similar examples, but I want to do something that's a little different. Let's do number 4. All right, what this is asking me is, what values of x is the graph concave up and concave down? Now, what concave up and concave down mean, it's referring to the curvature of the graph. So the graph might do something like this. And this part of the graph is concave down. So notice the way this curve is curving downwards. So we say this is concave down. This part of the graph here is curving upwards. So we say this is concave up. So to find concave up versus concave down, we use the second derivative, y double prime. And we're basically going to follow the same procedure as we just did for increasing, decreasing, but we're going to use y double prime instead. So let's follow the same steps. All right, well, first thing is, let me start out with y prime. Well, when I take the derivative of x to the 4, that's 4x to the 3, but it has a negative in front. Then I'm going to take the derivative of x to the 3, that's 3x squared. The derivative of 16x is just 16, and the derivative of a constant 3 is just 0. I'm using this derivative rule that says when you want to take the derivative of x to an exponent, you bring the exponent down in front as a multiplier, and then write x with an exponent 1 less than the exponent you started with. All right, well, what we have here then is y prime is negative 4x to the 3 plus 48x squared minus 60. But we need the second derivative. For concavity, we need the second derivative. So let's do it again. I'm going to take the second derivative. Second derivative. This -4 comes with me. The derivative of x to the third is 3x squared. This 48 comes down with me. The derivative of x squared is 2x. And the derivative of a constant here is 0. Let me clean this up. This is -12x squared plus 96x. But we set this equal to 0. And I'm going to factor out a -12. If I do that, -12x. And if I do that, that's going to leave me x minus 8. Yeah, x minus 8. All right, now I'm going to set each one of these parentheses separately equal to 0. So that's going to get me x equals 0 here and x equals 8 here. All right, I make up a number line with x equals 0 and x equal 8. And I pick a test point in each interval. So let me pick a test point back here. Let's say x equal -1. I'll pick a test point here in the middle somewhere. I'll say x equal 4. And I'll pick a test point over here, maybe x equal 10. Right, you'll pick probably different test points, but you can pick any value you want for x as long as it's within the interval. All right, now we're going to evaluate the second derivative for each one of these test points. So let's do x equal -1. All right, here's the second derivative function. So again, all I care about is the second derivative positive or negative? If the second derivative is positive, that tells me the graph is going to be concave up. If the second derivative is negative, that tells me the graph is concave down. All right, so let's work out y double prime. I'll call this interval A, B, and C just for labeling purpose. So let's do x equal -1. So y double prime is -12 times -1 squared plus 96 times -1. Remember, all I care about if it's this positive or negatives, well, this is going to be -12 minus 96. That's definitely negative. Okay, so we just found in this interval, the second derivative is negative here. Okay, let's go to interval B. Now I'm going to evaluate the second derivative at x equal 4. So this is going to be -12 times 4 squared plus 96 times 4. What's that? -12 times 48 plus 96 times 4. Let's see, I'll work this out with my calculator helping out here. So I do that and I work this out. I'm getting the result -200. So this is negative here. All right. And let's go and do the third interval. And the third interval is when x equals 10. Okay. All right, so let's do interval C. So interval C, that's for x equal 10. So y double prime is -12 times 10 squared plus 96 times 10. All right, this is going to be -120 plus 960. And so that is going to be, excuse me, -1,1200 plus 960. So this is going to be definitely negative. Oh, folks, I see a little mistake I made here. Whoops. This 4 squared here should be 16, not 48. So Let me fix that. Sorry, this should be a 16. So let me double check this now. This is negative 12 times 16 plus 96 times 4. This turns out to be a positive here. This is positive 192. So this should be a positive. All right, well, here's our summary. Interval A, we found the second derivative was negative. Interval B, we found the second derivative here was positive. And for interval C, we found the second derivative was negative. So let's summarize this. So we found the second derivative here was negative. Well, what that means is in this interval, the graph is concave down. Remember, when the second derivative is negative, that tells you concave down. Here in this middle interval, the graph is concave up. And on this far right side, concave down. So where is the graph concave up? Well, this middle interval is between x equals 0 to x equal 8. So x is between 0 and 8. Where's the graph concave down? Well, x less than 0 and x greater than 8. Okay, so x greater than 0, x less than 8. Okay, then it wants to know, what are the points of inflection? Well, a point of inflection is any point where the graph changes concavity. So here the graph was concave down, but now here it flips to concave up. Now again, it flips to concave down. So these points are called points of inflection. Wherever the concavity changes, it's a point of inflection. So a point of inflection is going to be, I'm going to, I guess, clear everything here. No, I better not clear everything. Let me just erase some of this here. So what we're seeing is the points of inflection. Points of inflection are at x equals 0, because the graph went from concave down to concave up, and x equal 8. Now in this problem, it wants an ordered pair. So I need to also figure out the y value. Well, the y value here is going to be plugging in the x value into the original function. So to find the y value, when x is 0, I could just work out y equals negative 0 to the 4th plus 16, 0 to the 3rd, minus 16 times 0 plus 3. Well, if I work that out, I just get a 3. So this point is 0, 3. And I could do the same thing for x equal 8. Y equals negative 8 to the 4th plus 16, 8 to the 3rd, minus 16 times 8 plus 3. And if you work that out in your calculator, you get 3971. So this inflection point is 8, 3971. Okay, so what we did here is we used the second derivative to tell us about concavity. All right, folks, why don't we do another example? How about if we do an example here? It says y equals 4x squared plus 4x. Well, I can check out what's happening here by using the first derivative. So let me go ahead here and find the first derivative. So y prime is 4 times the derivative of x squared is 2x. The derivative of 4x is a 4. So y prime is 8x plus 4. I'm going to set this equal to 0. Then I'll subtract 4 from both sides. So I'm getting negative 4 equals 8x. Divide both sides by 8. So it looks like x equals negative 1/2. So I'm going to go to a number line and mark x equal negative 1/2 here. All right, Well, I'm going to pick a test point over on this side, maybe x equal -1. And I'll pick a test point on this side, maybe x equals 0. Right? It's always a good idea to pick x equals 0 because that makes a test point is x equals 0. That makes the calculations a little easier to work with. All right, well, now the next step is evaluate the second derivative for each one of these test points. All right, so let's do it. Y prime is 8x plus 4. So this is going to be 8 times -1 plus 4. That's -8 plus 4. I could see that's negative. Well, that means the function is decreasing on this side of x equal -1/2. Let's come over here. Y prime is 8 times 0 plus 4. That's 0 plus 4. That's positive. So the function is increasing on this side. All right, so here's what we have. On to the left of x equal -4, the function has to be decreasing and then increasing to the right. Well, the only graph that matches is this graph right here. And if you notice, this point here is x equal -1/2. This graph C is wrong because this point here, x is positive 1/2. So graph A here makes sense as the correct answer. All right, let's do a couple more. Let's take a look at this one. This one is asking us to find the dimensions of the largest shed that can be built. What's its area? All right. So what they're asking us to do here is maximize area, subject to a perimeter of 56 feet. Let me draw a little diagram. Here is the rectangular shed they're talking about. I'll call this X and Y. So we want to maximize the area. Well, I know the area of a rectangle is X times Y. And anytime I want to maximize or minimize, I take the derivative. Well, before I take the derivative of area, I want to get only one variable in this equation. Notice right now I have an X and a Y, but I only want one variable, either X or Y, but not both. Well, here's where the perimeter equation comes in. Because if I think of the perimeter of this rectangle, it'd be 2x plus 2y equals 56. Let me divide both sides by 2. So that would be x plus y equals 28. Well, what I'm going to do here is solve this equation for y. So if I have x plus y equals 28, I'm going to subtract x from both sides so that y equals 28 minus x. Well, this is the ticket I need because that means I'm going to take this y and replace it with 28 minus x. That means the area is 28x minus x squared. All right, remember, we want to maximize this area, okay? Because it said the largest shed, that means maximize the area. Well, anytime you want to maximize a quantity, take its derivative and set it equal to 0. Because max and mins occur when the derivative is equal to 0. All right, so I'm going to call this a prime for the derivative. I'm going to bring the 28 down. The derivative of x is just 1. And the derivative of x squared is 2x. I'm going to set this equal to 0. So I have 0 equals 28 minus 2x. I'll add 2x to both sides. That means 2x equals 28. Divide both sides by 2. X equals 14. So we know this one dimension here, x is 14. How about y? Well, here's an equation that I could use to figure out y. Y is 28 minus x, but we just figured out x is 14. So y is 14 also. So the dimensions are 14 feet by 14 feet. What is the area of this rectangle? Well, area is just the length times the width. So in our example, 14 times 14 is 196. We use square feet as the units. So that's the area of the largest shed possible. All right. Folks, let me do, let's do maybe one more. And if we come here, all right, it says, let's see here. It says you're going to cut a rectangular hole in a wall. The perimeter of the hole is 48 inches. We want the length of the diagonal to be a minimum. All right, well, let's draw a little rectangle here. This is the hole in the wall. Again, let's call this X and Y. They're telling me the perimeter is 48. Well, the perimeter is 2x plus 2y. That's equal to 48. Let's divide everything by 2. That'll be x plus y equals 24. Now, in this case, they want me to minimize the length of the diagonal. The diagonal is this line going from one corner to the other corner. So this is the diagonal. We'll call it D. Right? Let the diagonal be D. But this is really a right triangle here. So I can use Pythagorean theorem. Pythagorean theorem for a right triangle would say D squared equals x squared plus y squared. We're going to want to take the derivative of this quantity because we want to minimize, right, the diagonal. All right. Well, again, I want only one variable to be on the right here. I don't want x and y. I want just x or just y. Well, let me come down to this equation. X plus y equals 24. Let me subtract x from both sides. So y is 24 minus x. So let me go and plug this in. X squared plus, in place of this y, I'm going to drop in 24 minus x squared like that. All right, this is the equation we want to minimize. All right, well, here it is. It says write the equation to be minimized. Well, this is the equation we just wrote. All right, well, let me multiply this out now because I want to take the derivative, but here's what I'm going to do. I'm going to multiply this as 24 minus x times 24 minus x. All right, if I do that, I'm going to end up with 24 times 24. That's 576. I'm just doing a FOIL multiplication on this, right? Minus 24x minus 24x plus x squared. So that means d squared is 2x squared, because I'll combine these guys together. 2x squared minus 48x plus 576. All right, I'm going to take the derivative of both sides, because if I minimize d squared, that's going to minimize d also. So let me take the derivative of both sides. So I can think of it as taking the derivative of this quantity. Well, this 2 comes with me. The derivative of x squared is 2x. This 48 comes with me, and the derivative of x is just 1. So this is 4x minus 48. Set this equal to 0 to find the minimum. I'll add 48 to both sides. So I'm ending up that 48 equals 4x, x equals 12. All right, but I also need to find y. So we just found that x is 12, but we need to find y. Here's the equation for y. So this is going to be 24 minus 12, which is also 12. So y is 12. So the length of the diagonal is a minimum when the hole is 12 by 12. You notice this is a square. So the length of the diagonal is going to be minimized when you construct this vent as a square. Okay? So folks, for these kinds of problems, what you do here is you write an equation for the quantity to be maximized or minimized. But you want the equation to only have one variable. Get the equation to have only one letter in it, one variable. You don't want X and Y in the equation. You only want X or Y. So usually there's a second equation that's given to you. In this case, it was the perimeter equation that let us substitute for Y and get this equation that only had X in it. That's what we want. Then take the derivative and set it equal to 0. The reason you set equal to 0 is the derivative is equal to 0 when you encounter a max or a min. And that's really what we're being asked to find here in these problems is max mins. All right, folks, give this homework a try, please. Let me know if there's any questions. And remember, you can use the Ask My Teacher button, and I'll be glad to help out. All right, thanks, folks.